Alrighty, welcome back to Fun Maths. Today we're looking at average rates of change or average rate of change. Um, and this is activity 16C. So first thing we need to talk about is average speed and how we would go about working this out in this particular exercise. So essentially, regardless of what speed you're going, you can get an average speed over a complete journey, and in particular there is a formula that we're going to use for that. In general, to work out the average speed, it's the total distance traveled divided by the total time taken. And so as you can see here, there were different speeds that were traveled um, with this particular example, but if you were going to get the average speed for an object between two particular points, so in this particular point A in time and B in time, essentially what's going to happen is it's going to be the slope of the graph passing through these 2 points at point P and point Q. Straight line there. An example to illustrate this is as follows. So it says here, the graph of the distance travelled in meters against the time seconds for a motion of an object is shown. Perfect. It's asking us to find the average of the object in meters per second over the interval from time 2, so from this particular point, to time 12. Alright. So again, ultimately we're going to be looking at the gradient of the line connecting both of those. If you think back to the olden days where you have some coordinates you need to find the gradient of a line, and we had values, this might have been called x1, this one might have been called y1, and the other coordinate was x2, imagine that's x2, and y2. So what would happen is you would do y2 take away y1 divided by x2 take away x1. Yep, and the same difference here. We're going to be doing that. We're going to have the 30 take away the 12, which is the total distance traveled, divided by the 12 take away the 2, and we can work out the calculation from there. It is 1.8 meters per second is the average speed in that example. Now, some terminology again when you are working through these. If we're looking at the average rate of a function, average rate of change for a function, the line which passes through 2 points on a curve is called a secant. Cool. And the line segment that actually joins those 2 points on a curve is called the chord. Perfect. That's useful to know. So here is the fun bubble box that talks about the average rate of change. So it says for any function y equals f of x, the average rate of change of y with respect to x over the interval from a to b is the gradient of the line that goes through those points. So it goes through the point a, the coordinate a, f of a, and b, f of b. So that is the secant from a to b. Yep, is the gradient of that line. So to work out the average rate of change, as we discussed before, it's going to be the f of b value take away the f of a value divided by b take away a, and that will give you the average rate of change. Cool. So again, here's another example. Again, you've got some coordinates. To find the average rate of change of this particular function, we're looking at this gradient of the secant between p and q. And so to calculate that between the interval 1 and 2, it's going to be this value here, 4 take away this one here, 1. That's going to be divided by 2 take away 1. So we get the gradient of that particular secant, which in this case is 3. Other ways in which they can ask you these types of questions are like this. It says here, find the average rate of change of the function with the rule. It's got f of x equals x squared, take away 2x plus 5, as x changes from 1 to 5. So again, what we need to do is work out the average rate of change, which we know is the change in y, whether you want to use this notation here or you want to remember it as y2 take away y1 over x2 take away x1. It's the same difference. So what you would need to do to work out the change in y is first of all substitute in 1 into the function, so find f of 1. Once we find out what that is, it's 4. We're going to do the same thing when x is 5, plugging it into the equation. F of 5, it comes out to being 20. So to find out the change between the two of those, obviously we would do the 20 take away the 4 on the top line, which gives us the change in y. Change in x, obviously as you go from 1 to 5, the difference between those, the change, you would do the 5 take away the 1 is obviously there it is 4. You can do the 16 divided by 4, which is 4. That is the average rate of change there. Last one I want to speak about second last one I want to speak about is again finding the average rate of change of this particular function, and it's between -2 and 5. So the good news is they've given us the coordinates of a and b. We'd obviously need to find out the gradient of the secant between those 2 points, a and b, and again it's going to be the average rate of change between those 2 spots. It's going to be 20 take away 4 divided by 5 take away -2. Now remember, when you do 5 take away -2, take away a negative is the same as positive. Yep, so it's 5 plus 2. And we get that fraction there. This is a good one. It's the air temperature question. Cool. It says the air temperature in T degrees Celsius at a weather station on a particular evening is modeled by the following equation. Perfect. And this is where T is in time in hours after 6 p.m. So the first question is saying, hey, let's find out what the temperature is at 6 p.m. So because T is in time after 6 p.m., 6 p.m. is time equals 0. Yep. So plugging in 0 into this air temperature equation, we get 20 degrees. Next one, we're saying, hey, find out what the temperature is at midnight. Hopefully you know that if the time is 0 is 6 p.m., it's going to be 6 hours later, it's going to be midnight. So it's the same as time or T being 6. Because it's 6 hours, midnight is 6 hours after 6 p.m. We're going to substitute 6 into the temperature equation. You can see here where T is, we've substituted in 6. It comes down to 100 over 13, which as a decimal is 7.69 degrees Celsius. Again, it says find the average rate of change of the air temperatures from the 6 p.m., which was this first part that we worked out, until midnight. Yep. So to work out the average rate of change, it's going to be the difference or the change in y, or in this case, the change in t. So the change in t was obviously this 100 over 13, take away the 20 on the top line here, divided by the change in the x values, or in this case t. So it's going to be 6 take away 0, and we get this particular fraction here. -80 over 39. That simplifies down to -2.05 degrees Celsius per hour. Thank you very much for listening up. I hope that you have fun with this particular exercise. Bye for now.